Hey guys, Buildzoid here, and today we're going to be doing a video that I originally wanted to do right around the 3090 Ti launch. But I never got around to doing it because it's a rather speculative, and I don't really like doing very speculative videos because you can believe whatever you want, but that doesn't make it true. And so, like as much as if like this is basically purchasing advice that I would follow because it's like my own advice, right? It's my belief. If you're not going to believe something if you don't think it's true. Um, but I don't have any like hard evidence to back up uh, my belief here. So basically, I believe that a 3090 Ti is a much better purchasing decision than a 3090, mainly because a 3090 Ti should be way more reliable than a 3090, because 3090 Ti's are just built better than 3090s are. Um, and that's it. That's basically everything. That's the whole thing. Is like I believe 3090 Ti's are a better purchasing decision because they're less likely to randomly die. Um, and the reasoning for that is well, let's just get into it. So the first big difference you get between 3090s and 3090 Ti's is the power stages that are used. This is a Founders Edition 3090 Ti, and it uses these monolithic power systems MP86957 smart power stages. Actually, if we go to the documentation, well, the point is these are 70 amp smart power stages, but we do want the actual performance curves because the nominal current spec, like there are 90 amp parts that perform like 70 amp parts out there. Now, admittedly, I've not seen any 70 amp parts that perform like 50 amp parts, but once you get into the really high current ratings, you get a lot of sort of like, this isn't really, like the nominal rating becomes a bit less and less useful because it's more of a performance class than an actual useful practical uh, application, right? And you can even see that in the typical like characteristics here for the MP86957. This is a 70 amp smart power stage. They only give you performance curves up to 60 amps because realistically you should never be pushing 70 amps through this power stage because that would be really bad because it would be producing ridiculous amounts of heat and it would be completely uncoolable. It would be doable, but you wouldn't really want to be doing that. Like it is technically doable. That's why it's called a 70 amp component. That's why it's called a 70 amp smart power stage, but it's not practical. Um, anyway, so that's sort of the first big difference that you get between 3090 Ti's and regular 3090s is that 3090 Ti's use 70 amp smart power stages. This NVIDIA card uses, like the Founders Edition uses them, which isn't really a difference. The original 3090 Founders Edition was also on the same power stages. There was just less of them. Then you have the 3090 Ti from Zotac here, which uses more of those MP86957 power stages. We have this reference card PCB from Inno3D. That's more of the same monolithic power systems MP86957 power stages. Like, I have yet to see a 3090 Ti PCB that uses anything worse than a 17 amp smart power stage. On the flip side, a base model 3090 uses 50 amp to, well, 50 amp DRMOS components. You have parts like this, which are AL double zeros from Alpha and Omega Semiconductor, which the AL double zero, if you actually, unfortunately, they don't have a part number decoder as far as I know. So you have to manually go through the data sheets to check the last page to find the one, like the part number code. But anyway, so this is an AL double zero, and that's also known as the AOZ 5332. And 5332 is a 50 amp DRMOS component. And if we look at the performance curves for this thing, they are worse. They are just straight up worse. Now, mind you, as far as I can tell, this is spec'd at 1 volt output voltage. And the reason that's significant is because at higher output voltages, your power stages produce more heat, even though the efficiency goes up. Like you can see that the 1.8 volt curve has a higher peak efficiency compared to the 1.2 volt curve, but at the same time, that 1.8 volt curve just across the board is producing more heat, right? At 60 amps, like that 1.8 volt curve is giving you like 12 and actually close to 13 watts of heat output at 60 amps compared to like 11 compared to 1.2 volts. Now, the reason why the efficiency curve goes up is because the increase in heat output is not proportional to the increase in output voltage. So if you increase your output voltage by, I don't know, like this is what, like 50%, something like that? Is literally 50%. Yeah, going from 1.2 to 1.8, that's literally 50%. So you increase your output voltage by 50%. So your power output goes up by 50%, but your heat output is only increased by like 10, 20% or something like that. And so, you get a nice bump to efficiency but your heat output still goes up. It's just, it goes up less than the output power goes up. Anyway, I point that out because I'm pretty sure all of these alpha and omega semiconductor parts are spec'd at 1 volt, just because all of the few AOZ 53 series parts that you do have output voltages for are 1 volt. Right, this one we don't have any information, but this is a 5311. This is another DRMOS component used on 3090s, and this is spec'd at 1 volt. Alpha and omega semiconductor parts really are very popular on NVIDIA GPUs, so I'm assuming everything's spec'd at 1 volt, because typically NVIDIA GPUs run at around 1 volt. So, yeah, anyway, if we look at the performance curve here at 30 amps output, at 300 kilohertz switching frequency, this thing produces 3.5 watts of heat. For comparison, the monolithic power system MP86957 at 30 amps output is producing 3 watts of heat, right? Because it's literally midway between 2 and 4, and that's at 1.2 volts and 500 kilohertz switching frequency with less output. I'm pretty sure that's with less output inductance. Actually, we don't have an inductance spec here, so this documentation's not that helpful. But yeah, so there's a slight efficiency improvement. And really, the thing is, we can't compare the efficiency curve because at 1 volt output voltage, your efficiency curve is going to be kind of miserable compared to 1.2 volts or 1.8 volts, because of the whole output power increases quicker than heat output of the power stages does. But anyway, then we also have the 5311. This is actually a slightly better part. This is a 55 amp part. This is used on the Gigabyte 39, reference-esque 3090s. And this is a BLN0. And if we scroll down to the last page of this, yeah, it's a BLN0. So anyway, this is slightly better than what you get on most 3090s. If I could find the performance curves again. There they are. So yeah, actually, no, it's not. They have a different scaling. Yeah, so this is 30 amps, and that's 3.4 watts of heat, maybe. It's 3.5, basically. It's slightly better. It's a little bit below halfway mark. Actually, I think this was also slightly below the 3.5 watt mark, right? Yeah, this is slightly... Actually, so they're the same. So basically, this is a 55 amp DRMOS component. Same performance as the 50 amp DRMOS component. And this is why the nominal current rating is kind of freaking useless. Because yeah, if you can get a bunch of parts with if they're a couple amp, and well, so for the low end parts, if they're a couple amps apart, they're probably going to be the same. And then for the high end parts, there's actually a huge range of parts where from there are parts from 60 to 100 amps that all perform the same. Yeah, nominal current ratings, not really all that useful. Anyway, the 70 amps more power stages used on 3090 Ti's are better than the DRMOS components you find on 3090s. Mind you, these aren't even the worst parts you can get on a 3090. I've seen some 3090s use even 45 amp DRMOS components. But I didn't want to pull up a whole bunch of data sheet, and these AOZ parts are very, very common, and they're typically 50 to 60 amps when they're used on a 3090. Anyway, so that's one thing, is just so a 3090 Ti just has better power stages. And one of the neat things with these better power stages is actually these have a short circuit protection built in. You have, yeah, low side catastrophic fault flag and protection, which basically what this does, well, we'd actually have to go through the paragraph for that. I don't feel like doing that. But the documentation is public, so if you want to read about all the safety features that this smart power stage has, you can go look through that. Whereas these parts basically, I think they have a thermal warning system, and that's about it. If they even have a thermal warning system. I mean, they do have under voltage, but that's basically if they don't get enough like voltage to run, they're gonna shut down. That's not gonna save you in an overload scenario. Whereas this function is designed to help in an overload scenario because you have all of the like current limiting and that kind of thing, as well as actually just power stage like MOSFET failure protection. Whereas these just kind of don't do anything like that. Which combined with the way the overcurrent protection is configured on 3090s means 3090s will literally run their VRM into the ground if, for whatever reason, the shunts aren't registering a high enough power load or something. So, yeah. Um, and to Yeah, so these also don't have any kind of thermal protection, which makes sense. Like, these are called DRMOS components for a reason, and Alpha and Omega Semiconductor does make some smart power stages, if I remember correctly, and those have protection features, because that's kind of the whole point of that component naming distinction is, like, smart power stages have a bunch of extra features built into them. DRMOS components are basically just a driver and two MOSFETs, and anything you get on top of that, including, like, temperature monitoring or temperature limits or anything like that's, like, nice extras that are completely optional for a basic DRMOS component. Anyway, so 3090 Ti's have better power stages that should just, like, they're more efficient, they should be more reliable, they have more safety features, which sort of goes into the whole should be more reliable. Other than that, 3090 Ti's have just more power stages, right? So it's not actually an 18-phase design. The controller on these cards is a new controller. We have the MP2891. This is a 16-phase controller. As far as I can tell, it probably runs in 12-phase mode on most 3090 Ti's for the V-Core, and then 3 or 4-phase mode for the memory power. But anyway, you do have 18 smart power stages in total on a 3090 Ti's V-Core, and you do not have the MSVDD rail, which is one of the sort of wacky power delivery things that 3090s do is, and I suspect the reason 3090s do this is because they use voltage controllers that literally cannot deal with the amount of current that 3090s can pull. So we have the UP90, like a lot of 3090s will use a UP9511 for their V-Core, and then also potentially a UP9511 for the MSVDD. Sometimes you'll also see a 9512 used for MSVDD, which would be like this card right here. You have a 9512 for MSVDD and then 9511 for V-Core, which just doesn't make any sense because this is the worst controller of these two. Like, this controller came out with the 2080 Ti. This, I believe, was originally designed for the GTX 1080 Ti. So yeah, this controller really isn't meant to be dealing with a 350 watt, like, power draw GPU, which might explain why the overcurrent protection is set sky high, because NVIDIA wanted to avoid GPUs randomly shutting down on people, so instead GPUs randomly blow up, or more like the power stages randomly die. Well, actually, I think I've seen one of these Zotac cards actually catch fire, whereas Gigabyte had the foresight to put fuses on their card, so when the power stages fail, you don't get a fireworks show because the fuses trip and then the card, like, still doesn't work, but or more like the fuses blow and you don't get a fireworks show from your GPU. And anyway, so basically, I suspect 3090s have this weird, like, MSVDD V-Core power delivery split because the UP9511 literally couldn't handle a single V-Core power delivery system for a 3090. Now, with the 3090 Ti's, we have a single power delivery system for all of the core current, right? There's just a V-Core rail, because we now have a brand new voltage controller from Monolithic Power Systems designed to handle probably absolutely stupid amounts of current, because it's a 16-phase chip. So, yeah. So now you don't need that weird, like, split core power delivery system. And the main concern I actually have with the sort of split power delivery system that a 3090 has is that potentially, if for whatever reason the V-Core rail is doing significantly more work than the MSVDD rail, you can end up in a scenario where the card is below its power limit, but overloading the VRM, which would also potentially explain a lot of the Amazon New World failures, because I think most of them were happening to the V-Core VRM. Basically, the issue here is that if for any reason the current draw isn't evenly shared between MSVDD and V-Core, and there's really no way for, like, the 9511 and the 9512, they can't talk to each other, right? They can't choose to dynamically, like, share power stages or something. Like, that's the whole reason you have two separate power outputs. So a 3090 theoretically could have its entire TDP shoved through just the V-Core VRM, and that would be really bad. The V-Core VRM on this card is actually 10 power stages, but on, like, say, this card, it's 9 power stages. On this card, it's 10 again. Like, it's not that substantial, right? Like, the whole idea behind the split V-Core MSVDD thing for 3090s is that in total you have at least 13 power stages handling the overall core power draw, except like 5 of those power stages are the MSVDD rail. So if for whatever reason those aren't working very hard, you know, V-Core kind of needs to do all of the heavy lifting. Which yeah, that's great. Don't have to worry about that on 3090 Ti's because you just have one voltage controller, so no matter what part of the core is getting taxed, all of your power stages are contributing to the power delivery. Like, there's no scenario where, like, part of the VRM is basically sitting there idle because they're all part of the same VRM. Anyway, so that's that. So basically, power delivery on 3090s is just vastly superior. I mean, 3090 Ti's is vastly superior to what you get on 3090s. And if you get something like, say, a 3090 Ti Hall of, well, not a Hall of Fame, like if you get like a 3090 Ti, say Supreme X, you actually get a VRM on this card that's just better than anything on any 3090 ever. Yeah. Like, there is simply no 3090 that has a VRM this powerful. Not a Kingpin Edition, not a Hall of Fame, not a Strix. Because, in fact, the base model 3090 Ti has a VRM comparable to what you get on a 3090 Strix. Actually, no, it's better, because the 3090 Strix uses 60 amp power stages. Not, they are actual, like, 60 amp smart power stages, not the RMOS components, but they're still not as good as the 70 amp parts that you get on 3090 Ti's. So, you know, power delivery-wise, 3090 Ti is just vastly superior to 3090s. Also, you have the new, better, like, power limiting system that, you know, prevents a lot of the really harsh transients that 3090s have. Probably also partially responsible for a lot of the power delivery failures on 3090s, but, hey, you know, high-end NVIDIA GPUs and the VRM failing is kind of a common thing. So you can't be too surprised. Well, actually, you know what I find really kind of annoying about 3090s is the PCB for a 2080 Ti was this, right? A 2080 Ti has a 13 power stage V-Core VRM using 70 amp smart power stages. Now, I think maybe the power planes or, like, some other details of the power delivery on a 2080 Ti are probably worse than on a 3090. But in terms of, like, actual component selection, 2080 Ti's are just, like, in terms of the power stages dealing with all of the current, like, 2080 Ti's just use better power stages than 3090s, which is ridiculous because 2080 Ti's were $1,200 and 3090s are $1,500. So I really don't know why that's like a thing. Like, and the funny thing is the 1080 Ti was also like a good VRM relative to its power consumption. So we had like 2 generations of NVIDIA cards where the power delivery was good, and then we went right back to, like, why is the VRM bit this? Why this? Why would you do this? Anyway, though I guess maybe NVIDIA's system here is that only the top end Ti cards get the good power delivery, and everything else just kind of gets whatever they manage to glue together. But yeah, so basically 3090 Ti is just better power delivery. Now, other improvements, and I don't know how intentional this one is, but they've moved the core and all of the memory chips away from the PCIe slot. And this is actually a relatively common issue with 3090 Ti's is that this memory chip, which is rammed right up against the PCIe slot, basically breaks. Because the PCB bends, the memory chip is far more rigid than the PCB is, and one side of the connection gives up. Either the memory chip pulls pads out of the GPU, or the PCB, which, as far as I know, it's actually far more likely that the GPU PCB pulls pads out of the memory chip, and then the memory chip loses connection to the core, and the card no longer works. And also, you can have like cracked solder balls on that memory chip. But from what I've heard, usually the solder actually holds up better than the glue holding the memory chip together. Or whatever. I don't know that it's glue, but whatever basically holds the pads on the memory chip. Yeah, that doesn't tend to be as strong as the solder balls, so you end up having to replace that memory chip on a lot of 3090s. And on 3090 Ti's, they've just kind of moved everything up, which should significantly reduce the bending stress on that memory chip right there. So that's good. And then you also have the improvement that 3090s have a bunch of memory chips on the back, whereas 3090 Ti's don't have a bunch of memory chips on the back. Now, I don't know how common it is for memory chips to fail from like thermal stress, just like straight up running too hot for too long, and I don't actually think it's very common, because there's an awful lot of GPUs where they literally have no memory chip cooling, and you don't really like I'm not aware of like memory chips just getting like burnt out unless they're running extremely hot for extremely long. And when I say extremely, the thing is we've also not had memory chips that pull as much power as GDDR6X does. So that is one of those things that, like, historically I'd say memory chips getting cooked to death is rather rare. But hey, 3090s could be the first cards to prove that to, be could be the first cards to prove that actually your memory chips can be cooked to death. You just have to put them on the back of the card and have no real cooling for them because they're on the back of the card. And it would be kind of silly to put an actual heatsink on the back of the card because then the card's going to be 4 slots. Most motherboards and systems aren't really designed around the idea of having a giant heatsink attached to the back of the card. So, yeah, that's another one of those things. Like, I don't really think that's a major concern. At least I'd like to believe that it's not a major concern. Just because, then again, this is NVIDIA we're talking about. So, and the reason I say that is because I really don't think NVIDIA cares if the memory chips on every 3090 die in 3 years from thermal stress. Because after 3 years, it's outside the warranty period, and they don't care. So, yeah. And the thing is, like, you also have NVIDIA GPUs where, like, the 980 Ti's, the V-Core VRM likes to blow up. Does NVIDIA care? No, because 980 Ti's are old, and they don't have to deal with they're not going to be RMAing those things. If the same goes for the memory VRM on 980 Ti's. So, yeah, like, we've not, there for the power stages, I have at least the evidence of like Amazon's New World blowing up 3090s is kind of, in my opinion, pretty good evidence that there's something pretty wrong with the power delivery. Because a properly designed GPU, worst case scenario, should just shut down. It should never suffer a power stage failure unless the components themselves are faulty. If the power stages you have on your card meet spec, and they still fail, you've either underspec'd your components or your VRM doesn't have safety features. In which case, you've also underspec'd your components. Like, if you're going to have a VRM with no safety features, you need to overspec the components, because if something goes wrong, there's no protections, right? Like, yeah. So, I like for the power delivery arguments, I'd say, I feel very much more confident about that than, say, the memory chips on the back being a major problem, but I do wonder about that. And it is certainly better to just not have memory chips on the back of the card, because they're just going to run cooler if they're, if they're attached to an actual heatsink instead of a backplate, which, yeah. So that's basically why I think 3090 Ti's are just better than 3090s, because you have better power delivery without the weird controller weirdness. The memory chips are further away from the PCIe slot, therefore less likely to suffer PCB bending damage. And the memory chips are also better cooled because you don't have half of them on the back of the card. And that's kind of that. Now, I don't know, like, I wish I could say if that translates into like a 1 year reliability improvement or a many year reliability improvement. Like, I'd be really surprised to see a 3090 Ti suffer a power delivery failure. I wouldn't be surprised to see that on a 3090 because we've seen a bunch of that already, right? Like, admittedly, there are also 3090s that are good, right? Like the Strix. Yeah. Like, there are 3090s like this, which basically look a lot like you kind of get 3090 Ti PCB vibes. Also, I wonder if that's why Asus puts their core so high up. Like, Asus is one of the only GPU manufacturers that I've noticed doing this. Like, their custom cards just put the core a mile away from the PCIe slot. Like, this is even higher up than what you get on the 3090 Ti. Like, I wonder if that's specifically to avoid the whole memory chip rammed like on the PCIe slot thing. That would be really cool to ask them about that. Because I think because there's quite a few 3090 like custom cards. Well, MSI also does it, but then you have like the EVGA card, which I think literally just has the core exactly where it usually is. No, this is the 3090, idiot. This card. Yeah, this like you have cards like this where the core just lives where it usually does, and then the VRM gets taller. Which this is honestly what I was expecting from a 3090 Ti when they were first announced. Like when I heard NVIDIA GPU 450 watts, I was like, man, that sounds terrifying from the prospect of like, how long is that card going to last? Because high power consumption NVIDIA GPUs, and actually high power consumption GPUs in general, are not very reliable because they do suffer a lot of thermal stress. But especially NVIDIA ones, you like not only do you have the thermal stress issues with NVIDIA ones, you always also end up having concerns about like, is the power delivery going to hold up? Because on 980 Ti's it doesn't. And so when I heard 450 watt 3090 Ti, I was like, they're just going to take a 3090 PCB and stretch it, and that's a terrible idea. So I'm really like I was surprised when I saw this, and I was like, wait, this is like good. Like, really, anything you could complain about on a 3090 is just not present on this PCB. The 450 watt power limit is still kind of like, it's probably not the best for reliability. But if you undervolted a 3090 Ti, or if you literally just took the power limit slider and slid it down to 350, right? So you set the power limit to the same level as what you have on a 3090. A 3090 Ti should just outlast a 3090. By a very large margin at that point. So, yeah. Oh, and also the 12 pin is dumb, in my opinion. And the reason I say the 12 pin power connector is dumb, I mean, on one hand, I understand why it exists, but basically, 8 pin. So, there we go. So this is an 8-pin power connector pin out. You have 2 sense pins, which basically means you don't have 2 useful full grounds, but then you have 3 12-volt lines and you have 3 grounds, right? So current comes into the GPU through the yellow pins, and current comes back from the GPU to your PSU through the gray pins. At least in theory, in practice, if you measure a GPU that's plugged in, like if the motherboard is powered by the same PSU as the GPU, a lot of the ground current will actually be going through the PCIe slot, through the 24-pin power connector. And I know this because I've tested it. But yeah, anyway, so the ground pins are actually less important than the 12-volt pins in a typical GPU installation. If you're using a multiple power supply setup, then actually all of the ground current returns through the actual ground pins, because technically 2 power supplies do share a ground through your like wall outlet, but yeah, they're not going to be like too much resistance in that path. It's too long. There's not going to be a significant amount of current flowing through that, if any. Yeah, anyway. So the point is the 8-pin power connector has 3 12-volt connections and 3 ground connections, right? And the new 12-pin looks like this. This has 6 12-volt connections and 6 ground connections. And this new 12-pin power connector replaces 3 8-pins, right? Like, the cards come with a triple 8-pin connector. And the thing I don't get is, how can you go from having 9 12-volt pins to having 6? Or more like, I do get it. Like, the whole reason the connector works this way is that with 3090s, or more like with 3090 Ti's, do they not show the stupid adapter? Aw. I was really hoping for a picture of the adapter. Maybe in the test setup? Oh, we don't actually get to... Oh, no, we do get to see it assembled. Yeah, so you have that, like, 12-pin to triple 8-pin adapter. Oh, wait, no, this isn't a 3090 Ti. Man! But everybody knows what I'm talking about. Basically, you get that three 8-pin power connector. And the reason that's set up the way it is basically you can't retroactively update the power spec of the 8-pin, because while an 8-pin power connector can quite happily do 300 watts, the spec for the 8-pin power connector is 150 watts. So there are power supplies out there that'll have like 2 8-pin power connectors that would definitely not be able to handle a 3090 Ti, but they do have 2 8-pin power connectors, right? So basically with the 12-pin, because this is an entirely new connector with a pinout that's incompatible with the old connector, you can set a new power limit, even if that power limit physically doesn't make much sense because the 8-pin was massively underspec'd. Like this power connector, I'm not saying that it's going to fail at 450 watts or even 600 watts. I really don't see any reason that it would have any issues with 600 watts. My point is that this connector is a lot closer to its actual physical limit than the 8-pin was, because an 8-pin, at least a good one, because again, there's some power supplies that'll use like 20 gauge wiring for their 8-pins potentially, which is a terrible idea. The minimum wire gauge that you should have on an 8-pin PCIe cable is like 18 gauge. And I generally like power supplies that use 16 gauge for anything handling any amount of power, that being the like CPU 8 pins, PCIe, 16 gauge cables are better. They'll handle more current. But anyway, the point is, because the 8-pin was like the original 8-pin spec is 150 watts, you can't retroactively go and change the 8-pin spec to 300 watts because that would cause a lot of issues. So now we get this new 12-pin power connector that's a lot closer to its actual physical design capabilities in terms of its spec. And yeah, I think I would have preferred if we just kept having more 8-pin power connectors on cards. Like, what's wrong with having 4 8-pins? Actually, no, 4 8-pins would be kind of... Well, the thing is, we already have cards with dual 12-pin power connectors for 3090 Ti's. But, yeah, because, like, I don't think I'd want to... Like, 3 8-pin power connectors, 900 watts, not really that concerning. I don't know that I would want to try push 900 watts through the 12-pin power connector, just because it literally has fewer current carrying connections compared to a triple 8-pin setup. So, yeah, anyway, but that doesn't, like, that really won't impact the reliability of the card. Like, that's mostly a concern for, like, extreme overclockers, is that, well, the funny thing about extreme overclocking is if you have enough airflow, a lot of the power connectors will actually handle way more current than they're rated for. Because the main concern is, like, if you push too much current through the connector, the resistance of that connection is going to produce a bunch of heat. And then, if the connector gets hot enough, it could melt, and that would be bad. But if you can just cool the connector, and that sort of solves that issue. So yeah, well, to some extent it solves that issue. You still have the problem of like the voltage, like you're not going to be getting anywhere close to 12 volts if you're losing a bunch of power in the power connector, but the VRM can actually compensate for voltage deviations to a pretty significant degree, so that's not as much of a concern as the whole like, oh, the connector might actually melt if you run it, overloaded for long enough. Um, anyway, that's it for the video. So again, this is very speculative, right? I don't have like RMA statistics to back up my dislike of 3090s, other than all of the very public failures in Amazon's New World MMO. But yeah, if I had $2,000 to spend on a GPU, or more like if I had $1,500 to spend on a GPU, I would save like I would wait several months to be able to buy a 3090 Ti instead of a 3090, just because I'd like to have a card that is designed for because like this is actually built to handle 450 watts, and there's really nothing I can complain about. Whereas this is kind of like the absolute bare minimum to deal with 350. And which is the norm for historically that is the norm for high-end Nvidia GPUs, like the absolute bare minimum to handle the stock power limit, which is also why a lot of 3090s have a power limit slider that really doesn't let you adjust it at all, because, well, if it had more adjustment range, that would be really bad, wouldn't it? Right? Like if we scroll down here, you start at 350 and you can go up to 385, and 10%, 3%, 9%. The Founders Edition has 16%. Actually, that's a 3080, not a 3090. That's that. Yeah, so that like a lot of the power limit restrictions are basically, well, the PCB is really not designed to handle much more than what it comes at. And in some scenarios, it still can't handle even what it's designed for, because, well, the thing is, the power limiting on 3090s is kind of slow, but yeah. Anyway, I should just end the video at this point because it's getting unnecessarily long, and I really don't feel like reshooting it. So, yeah, that's it. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, hoodies, posters, usual YouTuber merch. And then I also have a Bandcamp, which you might want to check out because, like, I make music. It's pretty harsh, is the best way I could describe it. So, yeah, probably set your set your expectations kind of low if you're gonna be checking that out. Anyway, that's it for the video. Thanks for watching, and goodbye.